Right, good morning, class. Thank you for joining me once again. Where, as you can see, I'm in outer space again. It's my own fault, really. I brought it on myself, and perhaps I wanted to. Who knows? But anyway, of course, my little video I made the other day about our good friend Nathan Oakley, Dorkley, has precipitated some commentary on my various social media accounts, including my face pages, where someone suggested to me, oh, yes, but Crepuscular Rays, though, Crepuscular Rays, this particular severely limited individual has suggested. And also, just to absolutely make clear and patent his severe limitations, he has guided my attention to a little video put together by a clearly very limited individual called P-Brane, which is ironic, isn't it? Of course, I know that he's actually referring to the fantasy of some of the aspects of theoretical physics there in a hilarious manner. But anyway, what's really hilarious is his cute little film, which of course talks all about crepuscular rays being the proof that the sun is small and it's close. So let's go and have a look at it, shall we? What fun.
Hey everybody, this is a video about the sunbeams or the sun rays that come through the clouds called crepuscular rays. And what I'm going to do here is prove in this video...
No, you're not P-Brane. You're going to prove yourself to be a P-Brane, but we'll get to that.
With a series of proofs.
No, a series of ridiculous ideas that can be dismissed within seconds. But as I say, we'll get to it.
Beyond a shadow of a doubt.
No, the only thing beyond a shadow of a doubt here is your severe limitations, P-Brane, in terms of your IQ, your wisdom, your knowledge of anything. Really, seriously, I think you should probably present to services, P-Brane, and get yourself some help. You should be under constant adult supervision. You shouldn't be left to be making your own decisions. It's not fair on you. Anyway, let's move on.
But the sun is close and the sun is small.
The sun is neither close nor small. It's 93 odd million miles away, and it's roughly 1 million miles in diameter. Both of those things, I think, qualify as fairly far away relative to anything here on Earth, of course, and indeed really quite large. So, good start so far.
First, I'm going to show you an experiment I did with the sun rays. That's very solid proof that the sun is, in fact, close. And
only if you have an IQ in single-digit figures. As I say, we'll get to it.
Not very big. And then I'm going to refute Wikipedia's account of...
Oh, well, if Wikipedia's got something wrong, that's the end of science, isn't it? Although, in the case of crepuscular rays, Wikipedia has not got this wrong. You have, P-Brane.
These.
Okay, it really is funny that you've chosen the name P-Brane, isn't it? I know I'm labouring the point a little bit, but whatever.
Crepuscular rays. They say that these rays are due to perspective.
They say that because it's true. That's how it works. Of course it is.
And that, in fact, they are, for all intents and purposes, parallel lines.
Brilliant. There you go, P-Brane. You have clearly shown us exactly what's going on there with the perspective issue, demonstrated with your nice yellow lines there. That should really be the end of your video, and you should go, oh no, I've messed up, haven't I? Yes, you have, son, because you've just shown us exactly how it really does happen, graphically. There you go.
From a sun that's almost 1 million miles in diameter, but the fact that we see them splaying out.
Yeah, so these vertical parallel sun rays have been computer generated. So why didn't you just take a photo of vertical parallel sun rays, P-Brane? Oh yes, that's right, because perspective is a real thing. And you can't do it because it doesn't exist that way in nature because of perspective. But we'll get to that.
They say that that's due to perspective.
That's because it is.
Going to show that that's impossible.
No, it isn't. You absolute P-Brane.
And then number 3, I'm going to show that it's actually, when you take a look at this picture of the crepuscular rays, that actually perspective is missing.
No, it isn't. It's clear and patent there. Goodness me, P-Brane.
From this photo, if in fact the sun were 1 million miles in diameter,
which it is,
and 93 million miles away,
which it is,
heliocentric model is in trouble.
No, it isn't. It isn't. The only thing that's in trouble here, I think, P-Brane, is the future of humanity, because there are still people moving around freely without constant adult supervision like you should have, being able to make these kind of videos. Really. Goodness.
So let's get to my experiment.
Your experiment. Okay, let's see your experiment, P-Brane.
I watched a video from my perspective. His video is called Flat Earth Sunbeams, Part 1.
There you go. So your research was to watch a video by another flat earther. Okay.
I was outside and I go, man, let me try that. And I just kind of ran in. I grabbed some cardboard. I cut.
Okay, so he's got 2 pieces of cardboard of the same sort of diameter there. The one that he's about to move has got some holes cut in it, and then with a pen, he's drawn around the outline of those holes with a pen onto the bottom plate. Okay.
Some holes in it, and I wanted to see how the sun reacts coming through. So here I am, raising it high over my head. So I'm about 8 feet away from this, and the light doesn't diverge.
So why is every single one of those areas that is lit by the rays coming through the board that you've raised up higher, why is every single one of those now outside the black lines, bigger than the black lines of the actual size of the hole as traced by the pen? It's almost as if they are splaying out from that point.
Or spread out. It doesn't splay out.
Again, let's look at the size of those light dots with respect to the size of the black shapes shown, even if you did line them up correctly, which he clearly isn't even able to do here. Not splaying out at all, are they? Goodness, P-Brane. That's embarrassing for you straight away, isn't it?
Like we see the crepuscular rays. And this
it's doing pretty much exactly that, isn't it?
Sun's far away. Just like in the heliocentric model, the sun is far away, right? 93 million miles away from our clouds. But we see the sun rays splaying out from the clouds
because of perspective, isn't it? Yes.
So it were a close sun.
No, as if it were subject to the laws of visual perspective, because it is.
Not a faraway sun. Well, you can see when it is far away, the light beams are parallel. And
no, look at the size of the dots. As I said, that's not parallel, is it? No, it isn't. Even at 8 feet.
They don't splay out.
Yeah, they do. Look at this, P-Brane. Can you not see the different size of these light holes with respect to the actual size of the holes in the cloud that allow those light rays to come through? Goodness, that's absolutely devastating for you. Oh, no.
Or diverge from the clouds.
Except they did, as we've just seen. Never mind the facts, though. We'll just ignore those and carry on with our ridiculous little video, shall we? What a good idea.
So then I got a little bit more sophisticated. I went inside and I cut some nicer holes in another cardboard. My budget went up. And here they are, and I put some CGI here.
Oh, well, there you go then. That solves it. That absolutely proves your point, that you could put some CGI on there. Excellent.
Put some beams in there, and you can see they are dead straight.
Except that when you look at the size of the light holes on the bottom plate, they exceed the size of the black lines that you've drawn when you've traced them directly on the size of the holes in the clouds, as shown by your very own experiment that you did a few minutes ago. So,
no splaying out. And then you can also, there's a part here where I have it up overhead, and I had the same results. No splaying out. So
except that you did, and we can see it clearly. And saying that it didn't happen a number of times doesn't change the fact that it does happen.
This is the example of the faraway sun, that the rays, this is what we should experience coming through the clouds. The rays.
So they're splaying out, aren't they? Because that hole there is bigger than that black line, and so is that one, and so is that one, and so is that one, and so is that one. Some of these are not parallel then, clearly. Whoops.
From a sun that's almost 1 million miles in diameter and 93 million miles away.
Which it is, both of those things, demonstrably, as shown by actual science, by actual scientists, P-Brane. Goodness.
When those rays get here, they should be parallel and dead straight.
No, they shouldn't, because of perspective, P-Brane.
But we don't see them as dead straight.
Because of perspective, P-Brane, a real thing, an actual phenomenon that we see. It's predictable. We can make predictions of what we should see on the basis of perspective, and we can test those observations by making some observations to see if we do see what we'd expect to see due to perspective, and goodness me, we do.
We see them splaying out or diverging from the clouds. Something's not right here.
Yes, the functioning of your mental faculties. That's what's not functioning here, P-Brane.
Okay, here I am inside. Notice I got my light close. Look at all.
So what we're doing here is vastly exaggerating the same effect that we have indeed seen already in the outdoor experiment. Exaggerating it. That's all. So what? What's your point? No point, of course, P-Brane.
Already you can see the light splaying out. You see that?
Yeah, we could see it on the outside example too, as I showed, P-Brane.
I drew you can see the
Go on, do it. Do it if you like. You'll see the same thing.
Circles on the floor and on my piece of cardboard, actually. Those are
So because something is a large effect, it's real, and if it's the exact same effect but less so, then you just ignore it and say it didn't occur when it was patently obvious to anyone with more than 2 brain cells and a functioning pair of eyeballs that what you were saying was not so. Okay.
The original size of the holes that when I was outside, they lined up perfect.
Look at the computer generated graphic there, which establishes absolutely nothing, because we actually saw the size of the sun holes on the bottom plate as exceeding the size of the black outlines drawn by tracing. So, no, P-Brane. No.
Perfectly. Here, you can see them completely splaying out.
Yeah, it's an exaggeration of the effect, of course.
And if I put the rays on it like this, the sun rays, and that's not even as...
That's not sun rays. That's more CGI, and that's not a sun. That's a small light bulb very close to the top of the clouds. That's not what we're seeing when we're looking at a perspective of a huge sun 93 million miles away.
Displayed out as they got. It's just that the cloud is...
So if you were to draw some straight lines along the left and right of this clearly doctored photo here, although that does look like what a crepuscular ray looks like, you will see that they will converge on a point where the center of the sun is in the sky at the time. No problem.
It's in view, and I want you to be able to see the cloud, which is my cardboard with the...
No, that's a piece of cardboard with holes in it, not a cloud.
Holes cut out of it. That way I could line up the rays, but as you can see, when I moved up a little bit off the floor and put the light even closer, the rays really splayed out. So I just wanted you to see that.
So congratulations, you can cut some holes in cardboard and put some light bulbs beside it and show what we exactly would expect to occur under those circumstances. We also saw the same thing occurring to a lesser degree with a much further away source of light as exactly what we would expect to see. But we didn't see no splaying, we did not see parallel rays, did we? Because if we did, then the light spots on the bottom plate in the outside experiment would not have exceeded the size of the spots. They clearly did. So, end of discussion. But clearly it's not, because there's still a good 16 minutes and a bit left of this joyous ride. So let's see what else he has to say, shall we?
Okay, so there you go. There's hard evidence that...
Of nothing at all, P-Brane. There's hard evidence of what you can expect to see and what you in fact do see when you play around with bits of cardboard and light bulbs and when you do the same thing outside using the sun. Okay, fine.
When the light source is close to the clouds, the light will diverge. The dispersion pattern you can see when I was outside, the dispersion pattern remained the same, meaning...
No, it didn't. We showed that clearly and patently. Stop lying to people. You ridiculous crackpot, P-Brane. That's crazy. It's absolutely insane. You need help. Get some adult supervision. 5 holes that I had that stayed exactly the same. No, they didn't, P-Brane. Not exactly the same at all. You absolute liar.
That's a faraway light source, but when the light source was close, they splay out. That definitely supports the flat Earth model.
Right, so here we go. Half of Australia is in the sunshine here and half of it is in the dark, despite the fact that this source of light is above the horizon. What's stopping half of Australia seeing the light at all? And why is it that the people who are right on this border here, where it's getting dark at the moment here, why are those people seeing the sun dip below the level of this so-called disk that we so-called live on? P-Brane. Explain that to us. Tell us how that one works. That'd be great. Also, nice of you to say not to scale for demonstration purposes only. Of course it's not to scale because it doesn't represent anything remotely objectively real. It's a ridiculous ideologically put together piece of non-science. It's a fantasy. It's ridiculous. Let's move on.
Of a small, close sun.
Okay, great. So now all of Australia is dark, despite the fact that there is a clear line of sight between the sun here and all of Australia, not to mention every other part of this entire so-called disk, P-Brane. Explain that one to us. What's happening? And why is it that these people living all the way around here are seeing the sun disappear below the horizon or come up over the horizon, as the case may be, depending on which side of that particular line of division they are on? What's going on? It's flat, isn't it? So why is the sun dipping below it when it's above it in other places? Doesn't that alone debunk your ridiculous ideology by itself? I think it does. Anyway, let's move on.
Okay, let's analyze this claim that science makes and Wikipedia makes that the crepuscular rays are due to perspective.
Okay, great. Let's see your analysis, P-Brane. This will be funny.
They're actually very close to parallel lines.
So not to scale, showing us absolutely nothing, proving absolutely nothing whatsoever. Again, that's a CGI picture. That is not a photograph taken from a perspective.
For all intents and purposes, they are parallel, coming from a sun that's almost 1 million miles in diameter, but we don't see them parallel coming through the clouds.
Because you can't see parallel lines unless you are looking at those lines orthogonally from 90 degrees away from the line of action. In other words, you would have to be looking directly at the horizon, and the sun would have to be, at that time, directly above your head. And then all the sun rays will appear to be coming down vertically all around you. If you look around 360 degrees, you will see the same thing. This is ridiculous.
Those crepuscular rays are angled outward.
Of course they are, because when you show these photos, like, here we go, that sun there is sending rays out around 360 degrees radially, because that sun there is not directly overhead, P-Brane, is it? No. It's a great deal lower than directly overhead, so of course perspective is at play. P-Brane.
They're diverging from the clouds. And Wikipedia is saying that that's due to perspective.
Because it is, P-Brane.
Okay, and Wikipedia also uses railroad tracks like these.
Yes, it's a great analogy for exactly the same thing, because you are looking at the light coming towards your eye. You are not looking at the light from an orthogonal angle, i.e. exactly 90 degrees away from the line of action of the ray of light. That's why perspective is at play. That's why we see what we see. Goodness, this isn't difficult.
And they say, see how these converge at your horizon?
There you go. You've just debunked yourself, P-Brane.
Or they diverge from the perspective of the sun outward. And they're
for exactly the same reason, P-Brane, because it's not directly overhead in this view, is it? Look, if you draw these straight lines to their point, the sun is going to be sitting somewhere about here, which is not directly overhead. You're not looking at those light rays from 90 degrees. Goodness.
They're saying that that's what's going on here. Okay, so we need a quick little review of perspective.
Oh, this will be fun.
Notice in this long hallway, all parallel lines and planes angle.
Goodness, it's almost as if this is a rule of nature and it works no matter what you're looking at. Perspective must be a real thing, because you keep showing us examples why it absolutely is a real thing, P-Brane.
Angle to the eye level or the eye position of the observer. Notice that the side walls angle in. Those are parallel lines to one another, and the ceiling and the floor are also parallel, but notice how they angle toward each other and they come to your eye level. All right, you have an X, Y, and Z axis. So the railroad tracks would fit your Z axis. That's going away from you, and those lines, yes, they converge. But the sun, and especially when the sun's overhead, would be bombarding us with huge vertical parallel lines.
Which is what it does when it is, in fact, directly overhead, P-Brane. This one here, converging lines, converging lines, converging lines. The sun is about here in this picture. That is not directly overhead. You are not looking at these light rays from 90 degrees away. No, you aren't. Goodness.
Or rays, parallel rays. Yet we don't see any of that ever.
There you go. That's where the sun is, about there, not directly overhead. Therefore, perspective is at play. You are not looking at those rays from a 90-degree angle. Goodness.
So what I'm going to show you here is that this claim that these crepuscular rays...
Why would we see that? Well, we would see that if, indeed, at that time, the sun were directly overhead, P-Brane. It isn't when you're seeing diverging rays. Wow.
This is due to perspective is not true. It's impossible, because
the only thing that's impossible here is to take you remotely seriously, P-Brane. How is this too hard for you to understand, other than because you have an IQ in the single-digit range, clearly?
Because perspective will not converge or diverge or splay out lines or planes that are parallel to one another.
Correct. If you look at it from 90 degrees away from the line of action, then you'd be right. As soon as it's off that 90-degree angle, you will see convergence, divergence. That's the law of perspective. That's what we see every day of the week and twice on Sundays, P-Brane.
That are perpendicular to the viewer or his Z-axis. Okay, so like in this picture of the railroad tracks here, the lines going away from you, that's I did with the green line, that's the railroad track, that's obvious. And right from the get-go, they start to converge. Now, those are parallel lines, but yet we never see them as parallel. They're always converging as they go away from you.
Perspective.
Now, the black poles that I have going down the side of the railroad tracks are also parallel lines to one another. But notice that they stay parallel.
Because they are orthogonal to the line of action of the vision in this case. So of course they do.
Don't lose their parallel orientation. They may get shorter and they get smaller. That's true. They do have a sort of a convergence, but they don't.
The top and bottom of each one of those poles is at the exact same distance from the eye. So therefore, they remain apparently vertical and apparently parallel, which they are in fact parallel so long as each one of those poles is indeed vertical. with respect to each other one. They're all exactly the same. Of course, as the Earth does curve a little bit, the angles will actually, over a very huge distance, but let's not muddy the waters with that. The reason that they remain apparently vertical and apparently parallel is because the top and bottom, to all intents and purposes, of each one of those poles is at the same distance from the eye. Okay.
Change their parallel orientation, these vertical lines, because they're perpendicular to you. Now, this is why invoking perspective to explain the crepuscular rays doesn't work.
Only if crepuscular rays were visible when the sun is directly overhead and you are indeed looking at 90 degrees from said light rays. If we saw crepuscular rays under those conditions, that would prove your point, P-Brane. But we don't. So your point is not proven. You're just saying words because you want to.
Because perspective does not splay out these vertical lines. Yet, whenever the sun is overhead, we should see vertical.
Well, there's not an example of a picture of the sun being overhead. It's higher than the level of the head, sure, but it's not directly overhead.
Parallel rays everywhere, and yet we don't see them. So perspective as an explanation for this is invalid.
No, it isn't. We've covered it.
What we see is the rays emanating from this.
Okay, so now you're looking directly up at a sun, let's say, that is directly overhead, let's say. In which case, the now nominal line of horizontality is across the screen through the middle of the sun, because that is now the perspective. That is what you are now looking at. So you're still going to see crepuscular rays looking directly up at the sun that's directly overhead. Of course you are. But if you turn your vision 90 degrees to the horizon and look straight ahead through the rays, which in this condition would be directly overhead, you would find that the light rays are vertical and parallel to one another to all intents and purposes. Goodness, this is not tricky to understand. I'll help you later with some pictures of buildings. I'll make it much clearer then, but let's move on.
Omnidirectional sun. The rays fit the size of the
Not overhead, is it?
sun, and the angles of the rays off the sun also fit the size of the sun and the shape of the sun.
So now you think that what is a lens flare is a real thing, a physical thing. You think these things have a set actual dimension in the real universe, and there's no change to what your eye would perceive by way of that kind of flare from different perspectives, about which you'd be completely wrong, wouldn't you, P-Brane?
But they shouldn't fit the size of the sun if the sun is in fact almost 1 million miles in diameter.
So that's just absolute nonsense with absolutely no even logic behind it. What on earth is that supposed to mean, P-Brane? What you are seeing there is a flare, a light flare. It changes with distance, angle, perspective. It's not a fixed thing. They're not physical structures. They're rays of light as you perceive them to be through the lens of your eye, and in this case, through the lens of a camera.
And 93 million miles away.
We know the sun is 93 million miles away, and we know it's about a million miles in diameter. We know that. Science has shown that with the actual math to show how it works. The fact that you can't understand that or can't accept that is not relevant here. The only time you will see the parallel lines of the rays of the sun is when the sun is directly overhead and you are looking at 90 degrees from those rays.
There you go. You hit it. Bang.
As covered.
The rays should be huge and the sun small.
No.
So that's telling us that the sun is in fact close.
No, it isn't. That's telling us that P-Brane is in fact a P-Brane.
Okay, and let's go back to what Wikipedia said. Wikipedia says that the rays from the sun are in fact parallel lines.
To all intents and purposes, yeah.
But we don't see them that way because of perspective.
Correct, which has already been covered more than adequately in this little film of mine thus far.
Perspective displays them out. Okay, look at this picture. I put these rays in.
Okay, so you've CGI'd that picture. It's invalid. It shows us nothing. It proves nothing then. Good, let's move on.
Okay, so this is what's really going on, Wikipedia says. They say that rays are really parallel, and they would be from a million-mile diameter sun. But
if you were looking at 90 degrees from their angle of action, which you are not.
This is what our eyes do through perspective. It displays it out.
Because we're not looking at 90 degrees from those parallel lines of light rays. P-Brane.
Okay, here's another one. They say this is how they really are.
Another CGI'd photo.
They're vertical and they're parallel, but our eyes display them out like this.
Because we're looking at it from a different angle, and thus perspective is at play.
Okay, so then why doesn't perspective take these telephone poles and splay them out like this?
Why doesn't it do that? If you were looking at telephone poles from a very low angle, looking up at them, then the bottom of the pole would be somewhat closer to you than the top of the pole, and you probably would see something quite similar to that, actually, like this. Because we're not looking at the face of that building or those buildings from 90 degrees away, are we? We're not looking at it orthogonally. We're looking at it from an angle, thus perspective is at play, and it appears that the buildings are no longer parallel and vertical, even though we know absolutely in reality and in fact they are.
There you go. You hit it. Bang.
Why are we seeing that, P-Brane, I wonder? Goodness.
We don't see that, do we?
Yeah, we do, as I've just shown, P-Brane, don't we? Yes.
Why doesn't it take these buildings and splay them out like this?
But you mean probably actually more like this? Yeah, you like that? Good. Okay.
They're vertical and they're parallel.
Yeah, because the tops and bottoms of those buildings, to all intents and purposes, are the same distance from the eye, because it's from a much further back standpoint, and therefore the angle is much, much closer to 90 degrees from the vertical face of those buildings, isn't it? Yes.
Well, because what we see, the crepuscular rays, is not due to perspective.
Yes, it is.
It's
as we've just seen from the analogy I've just given.
Due to the nature of an omnidirectional light source, with the light coming out in all directions. And it's coming from a small sun.
No.
It's impossible that this sun is 1 million miles in diameter.
No, it isn't. Because it is 1 million miles in diameter. And it is 93 million miles away, and perspective is at play anytime you're looking at light rays coming towards you from the sun, rather than looking at them from 90 degrees away, when they would appear to be parallel.
As I've already showed you.
No, you haven't. You absolute P-Brane.
So then if it's not perspective...
It is perspective.
These crepuscular rays are not due to perspective.
They are due to perspective.
As Wikipedia and science in general claims they are.
They claim that because that's what is going on. That's the explanation for the phenomena that we observe.
Then what are they?
Oh my God.
Well, it's very simple.
Yes, it is very simple. The crepuscular rays we see are due to perspective.
They are is radially propagated light.
Blah, blah, bloody blah, blah, blah. Finished.
Or another way of saying it, light rays emanating out from a common center. Like
the sun, 93 million miles away, and appearing not to be parallel because of perspective. Oh yeah, that, as shown by the building analogy we've just looked at. Let's look at another analogy just for fun. I mean, the one I was talking about that I said I would clarify earlier when we were looking directly up at the sun when it's directly overhead, thus changing what the perspective actually is, and thus meaning that you still see radial lines even though you have demonstrably parallel lines of light rays. Let's have a look at that one, shall we? Why not? Oh dear, P-Brane. Oh dear. Oh dear. Oh dear, P-Brane. You really are a P-Brane, aren't you, P-Brane? Yes, you are. Goodness me, goodness me, goodness me. That's embarrassing for you, isn't it? Are the sides of all of those 4 buildings absolutely parallel to one another? Yes, they are. Do they appear to be, if we take this at face value? Well, no, they appear to be radially emulating, don't they, P-Brane? That's unfortunate for you, isn't it? Shall we move on, perhaps?
The sun, or any light. And I understand that the light rays come...
You don't understand anything, obviously, P-Brane. Anything at all. Goodness me.
off the sun looks like perspective. It shares this...
That's because it is perspective, you clown. That's why it looks like it. Most things that waddle like ducks and quack like ducks, most of those things are ducks. I think you'll find, P-Brane.
The common trait where, with perspective, all the lines and planes converge.
Yeah, we've just covered this one, haven't we? With the buildings analogy. Good.
At a point in the distance called your vanishing point, the sun also has that look where looks like the rays all converge at a point in the center of the light.
Because they do.
Actually, the light rays are emanating out from a common center.
What's the difference? There is no difference. It's the same thing. In this analogy, looking directly up at a sun, the only light ray that's coming directly towards our eyes is the one right in the middle. Here. Every single other ray in every direction 360 degrees around that central point is splaying out because of perspective. It's really quite easy to understand, P-Brane, and not at all difficult. Let's move on.
But I can understand how they look alike, but they're not the same.
Yes, they are the same. We've covered this.
Okay, that's all it is.
No, you absolute P-Brane, P-Brane.
And so, as we've already proved that
No, you haven't proved a damn thing.
perspective can't explain the corpuscular rays.
It can, and it does, as I've shown, I think, more than adequately here in this video. It took me less than a minute to see what was wrong with your logic, P-Brane. Goodness.
Because where are all the vertical parallel sun rays then?
We've covered this. You look at them from 90 degrees away when the sun is directly overhead, and that's what you will indeed see.
Don't exist. Okay,
They do exist.
so next I'm going to show you with streetlights and sunlight and how they look exactly alike.
Okay, so a street light looks like sunlight because you're looking at it with a perspective, and so therefore that proves absolutely that the sun is small and close to us. You absolute P-Brane, P-Brane. No, I don't think so. I think we're actually done here, aren't we, boys and girls? I think we have put this one thoroughly to bed. Goodness me, completely ridiculous, wasn't it? Yes, it was. Well, there you go. I think that covers it pretty much. Perspective. Perspective explains the splaying out of the light rays from the sun when they are striking the Earth at an angle other than 90 degrees to the point at which we are stood on that Earth. Simple. There you go. Okay, enjoy the rest of your day, doing whatever it is that you're doing. I despair for the future of humanity. I really do. That there are still people in this world who are stupid enough to believe this ridiculous nonsense from absolute asshats like P-Brane. Good work, P-Brane. Good work. Anyway, enjoy your day, and we'll see you around later in the week probably, because people are probably going to keep being wrong on the interwebs, aren't they? And I'll have to keep putting it right. Oh well, see you then.